This is the line tracing card that I purchased for this project. It comes completely unassembled. You have to solder all the components on and mount the wheels and the battery pack and the nut in the front that keeps up the front end of it. It's a pretty easy little project if you have certain tools to do the soldering and check the components. I thought about using an Arduino to make the line tracing card, but for $5.55, I thought that was a good deal, and I got to learn a little bit about soldering and components and that sort of thing. The theory behind this line tracing bot car is very interesting. It uses it uses two LEDs, a left and a right in the front, and some photosensitive LEDs to register the reflective light from those red LEDs on the white paper or the black line of the track. And it, depending on which LED, photosensitive LED is blocked by the black line, less light gets through, and it triggers the opposite wheel to move the car a little bit to the right or to the left, depending on which way it needs to go. So I'm going to go down here a little bit and show you there are some pluses and minuses. It comes with all these parts. Unless you have really good eyes, these little resistors can be difficult to decode. Sometimes a red line looks like an orange line. Sometimes a silver looks like a gray. And you only get what, you solder it on this board. You got to be careful you do the right soldering. Now, in this case, it's not a big deal, but how do you know if any of the resistors are any good, or the capacitors, or the LEDs, or short of turning them on and testing everything? So what I did is I actually had bought this this little kit here. This little it's a tester, and you use the clips here to clip onto the leads of the components, and it tells you on the screen up here the resistor value or the capacitance value, if they're good, if they're bad. So this saved me a lot of time trying to figure out the little components, if they were good or bad, because some of the reviews said the components weren't any good and they had to replace them. So I highly recommend getting that. That made it really easy. Now, if you look here, this kit has two motors and a battery pack, and it has these metal clips. Well, the kit that I ordered is laid out slightly different. This whole PCB board is different also. So trying to look at the picture down here and figure out what's going on was difficult. Now, this is more close to what I have. It actually uses some double-sided tape here to hold the wheels on and the battery box. But you'll notice up here there's these metal clips. Well, these metal clips in the older version would come up through these holes and hold the motors to the board. Well, they reduce the weight and the cost, so they don't include it anymore. So I didn't even get any instructions on how to assemble this. I had to use just this picture. And the one negative thing about this picture is you don't see what the bottom looks like. It's difficult. They show a little bit here unassembled, but they don't show something assembled with the bottom. I actually found a picture that somebody had taken, and I kind of looked to see where components on the bottom go. There's actually I think this is the top. See, this is the top. I don't even know where the picture of the bottom of the board is. Here's a picture of the bottom. So here and here are the red LEDs. Mine actually says red LED 1 and 2. And then here's the photosensitive LED right here, and there's two of those. But when you read the instructions up above here, it kind of goes over really quickly how far those have to be installed. This actually has more steps than the one that I had. You have to go through different manufacturers, but right here it says the photosensitive resistance of the light-emitting diode, and you have to pay attention to the polarity, are installed in the reverse side of the PCB board. And the ground space is about 5 mil. the ground space. That means the distance from the ground up to it is up to the sensor is 5 millimeters, and the distance between the photosensitive resistance and the light-emitting diode is also about 5 millimeters. Finally, it can be tested with the batteries, but this is tricky. This whole thing here where it says 5 millimeters here and 5 millimeters here. Well, how much is 5 millimeters? Well, I looked it up. It's like 1/5 of an inch. So it doesn't really tell you how to install the car. Let me find the picture here again. Fully assembled. Here we go. So here's a fully assembled one. And they're talking about this, and then that, and then there's another one over here. And so it's tricky. You got to kind of guess. It's about, it's a thickness of maybe a couple coins, 2 or 3 coins. And then soldering it is difficult because getting in there is difficult. Now, the way around it is this nut right here. You can adjust it up or down. You'll need a second nut underneath this head of the bolt, and you can raise or lower the front of the car to get the LED lights and the sensors closer to this track down here, to the line of the track. And in the back of the car, which they don't show you, are 2 potentiometers that you need to adjust in order to set up these green lights. These trigger lights, they go on every time one of the photosensors is plugged up or darkened. The light will go on, and then the opposite motor will kick it over. Well, you got to adjust that. So there's really 3 adjustments. There's 2 potentiometers in the back, and then this nut in the front. And that's how you get it to adjust it to follow this track. Now, this is a much larger track. You get just a simple little oval in the kit, and they don't even show that here, but it's a bad photocopy. But I made my own copy, and I just cleaned it up and made it clear. You definitely need to do that. There is no user manual. No, there's no user manual whatsoever. So you have to really pay close attention to the components. Now, the board does tell you what components go where, the resistors and LEDs. I don't even think mine has this red LED. I don't think I have that. And my component, this microchip, is in the back. So mine's completely different. These are in front. I have these in front also, these diodes. So all in all, it's a little different, and you're going to need, you don't get these little micro screws, at least I didn't. These are probably for these metal brackets, but these are for, some of these might be for holding the wheels onto the motor. I didn't get any of those, and I had to find my own screws and mount the wheels, or else they pop off, mount them permanently. But still, for $5, it's a great deal. It's a good robotic car. It follows the line well enough, and so I'm going to use this, and I am using this for this project. This is the color sensor recognition module I used for this project. It's very basic. It only does red, green, blue color recognition, but that's all I kind of needed. I didn't want to do a whole lot of different colors. And for the price, I really couldn't not get it. Overall, the module worked very well. Finding software for it to control it using the Arduino was a little tricky. I couldn't really find anything out there that was really clean and easy to use. But I did find something out of MIT that seemed to work pretty well, and it wasn't too long or complicated. But overall, I'm very pleased with the module. It does on occasion misread a color, and that's probably maybe because I don't have it precisely 1 centimeter away, or maybe my color samples that I used with a coloring pen, felt pen, didn't come out quite right. So, but overall, the module worked well enough for me. If you're looking for something more precise, you may either want to buy a more expensive module, or perhaps get some sort of lens that goes in the threads into the module. I'm not sure that would make it more precise or not. It might be helpful. I need to kind of investigate that. I do have some different lenses, like a fisheye or just a close-up lens that you can buy for a couple bucks might help. So this is what it kind of looks like. Different views. That's the top looking down at the actual chip that recognizes the color. Here's a side view. Here's another side view. And here's a bottom view, and it has all the pins. And they are labeled. And you'll see that there's a voltage in. There's S1, S0, LED enable, disable, so you turn it on and off. A ground. And on the other side, there's a ground. There's an output pin, which is the data from the chip. And there's S2, S3, and then voltage. And the S2, S3, S1, S0, I'm not sure how those really work in conjunction, because the software I used controls that. So I'm not really sure what the S1, the S0 through S3 actually do. The LED pin turns on and off the LED, but somehow the sensor is controlled by the S0 through S3, I believe. I actually did not control those directly. Like I said, I used a program that was already pre-written that met my need. And in fact, it came out, it displays the red, green, blue values, and it also displays the white value. And that was very helpful because I actually on my project had 5 colors: red, green, blue, white, and black. And I was able to kind of detect all of those colors, although I did not use the white and the black. So I presume you could have probably have used this module if you really calibrated it to read the line, and instead of having the car use the photovoltaic cell, the photo cells, and go left or right, you could probably use this to stay on black. That would be a little tricky, but might be a little bit cleaner application, especially if you get this module dialed in really nice. But overall, I was very pleased with it. There was a little bit of critical positioning, making sure it's a certain distance off the paper, because it does have to read the value. And if you get it too far away, it doesn't read anything. Get it too close, it doesn't read anything. You had to get it just at a certain distance. The instructions say 1 centimeter, but I dialed it in for the car that I was using, and it seemed to work fine. Other than that, I was very pleased with it, and the color recognition was quite good. In addition to this module, I also used this module for sound. This is the EasyVR 3 multi-purpose speech recognition module. I've used this in other projects, and it's a very powerful little board. There's a lot here. You install these pins, and then you can plug it into a breadboard or into a shield. This is the microphone. This is the power cord, and there's 2 pieces of additional software that go with this that allow you to configure this board. So I'm sorry, this is not the power. This is the speaker. This is the speaker wire. I just realized that's a speaker wire. This is the microphone. You have to provide your own speaker. Not a big deal. You can get one on Banggood for a couple bucks, or for less than $1. In addition to the EasyVR 3 module, I bought this, which is the EasyVR 3 Shield for EasyVR 3, EasyVR Shield 3. I think it's really EasyVR 3 Shield, but nonetheless, I use this, and you install these pins, these pin blocks, and what it allows you to do is install the module on top, and then leaving these pin blocks available that plug directly into your Uno, your Arduino Uno. So you still have all the pins to use, which is great. In addition to that, as you're programming this module, there are jumper pins here at the top: hardware, software, PC, upload, one for Leo, I believe. And it allows you to quickly configure this board to do different functions depending on what you want to do. Do you want to play back and use it? Do you want to program it? Do you want to upload WAV files? It's much easier with the Shield. I highly recommend it. One thing I did find out was I had difficulty using this shield and module with an Arduino Uno, Arduino Wi-Fi board. I have an older Arduino Wi-Fi board that did not work so well. There may be a new Arduino Wi-Fi board that's out that I need to get and test it and see if it works. But well, what happened is if I put this in the Wi-Fi and I connected the power for the color sensor, the power right here, it shut the module off. And the module, the little red LED here, shut off, and so the board didn't work. So that took some while to debug. So use caution if you're going to try to use this with Wi-Fi. I'm not sure it actually works. But I don't know if that's a limitation of this board or a limitation of the Arduino Wi-Fi board, which I think it is. I think they probably had to steal some pins or change the property a little bit of the board. So like I said, I need to test that still. So getting back to this module and the shield, in order to make this work, this board do anything, you need to use a program called the EasyVR Commander. And this is what it looks like. You have all these different functions, and you have this group list and this word set. And as you click down here, different pre-coded actions and labels, command lists come up. One is stop, turn, right, left. This is the word set for this. This word set has other ones, and this one has, again, more, so you have quite a few. But these allow you to create your own, and the sound table, you can create your own sounds to play back. So a trigger is kind of like the Alexa trigger or Echo trigger. You say, if you program this in to your Arduino sketch, you can say a bunch of these words, but they won't do anything until you say the trigger first, like Alexa, turn, and then it'll work. But if you just say turn, it won't work. So that's kind of the concept. And then all these groups here, you can create your own special commands, voice commands. And what you basically do is, in order to train this, there's different. This program has several functions. One function is you train these groups to do different voice recognitions. Like you might have in this group blink, and you want to say the word blink, and then you want to make sure that word gets triggered. Well, to do that, you have to train it, and up here there's an option to train it, which is this right here, I believe. So you would create this group one, and it would be blank, and you would add a command. You could I think you add it right there. You add a command, and you type in the command name blink, and then you train it, and you have to go through it like 3 times, and then every time you click on it and you highlight it, you say the word blink, it would flash so that you know you've triggered that. And that would generate a code, a flag in your code. And what's interesting is once you've got all your little commands put in here, right up here, it doesn't say it, but because this is just a picture, but right here is where it will generate the code for you for your Arduino that has all your commands and sound wave files. And so that's critical to know. That took me a little while to figure out, that's the key, that's the button right there that actually generates the code for you. You don't have to type anything. And then you take that Arduino sketch and you modify it with your code to do whatever you want it to do. In my case, I modified it so that when the color sensor found a color like blue, it would say the word blue. And that's all I wanted. So mine was pretty simple, but you get to do much more complex things. And this is more of a command. If you want to play sounds back, then you need to generate a new sound table. And in order to do that, you use this program called QS5 Sensory Quick Synthesis 5 program, and you download it from their website. and it's an external tool for creating a sound table. And what you do is you record your own wave files. Mine actually says the word blue, green, red, and you have to create your own wave file. I use the Microsoft Windows sound recorder because it does have to be a very simple wave file. It can't be, I think it's 22 kilohertz, 8-bit mono. And what you do is you record a bunch of wave files on your desktop, and then you create a new file here, and you give it a name, like demo sounds, and it creates this QXP file. And then you click on this to add the wave files one at a time. And then when you're done with it, once you've added all your wave files, you then compress them, and then you build them. And it will build a QXP file. And that QXP file that contains all your encoded wave files. And what I was told, just as a side note, compress it twice and build it twice. That, for some reason, that always seems to work best. So once you've you've imported all your wave files and you've compressed them twice and built them twice, the project here would be called Demo Sounds QXP. You would then go back to your EasyVR Commander file or program, and right here is the upload of those wave files. And you click on that, and a separate box will come up, and it will direct you, it will ask you to select the file, the QXP file, and you got to find it on your desktop, and you select it, and then you say, there's a bottom window that you say build, and it will build. You'll see a little green bar go across in the box, and then it will say done. It'll come back to this main screen, and down here in your sound table, you will have all of your wave files that you've created. Whether, like mine says red, green, blue. And the sound table comes automatically with one sound, which is a kind of a bing noise or a ping noise. That comes pre-recorded, so that's already there. And so you will actually have, I had 4 sounds. And in fact, if you listen to my video, you'll see that, you'll hear that as the car is moving along and it's not reading a color, it makes a ping sound. That's what this is here. It's just playing that over and over and over until it finds a color. So these are the 2 programs that you need to use to create your voice recognition and your playback sound waves using the EasyVR 3 module and shield. So that was the second and third half of my car project, and for the most part, the first half, building the car, was just a mechanical thing. You just kind of do it and it gets done. Just make sure the components are good and that sort of thing. The second part is programming the light sensor to find the color and distinguish different colors. So I had to calibrate it. I actually had to kind of go through and check what were the most values for red, for blue, for green. And I found that for me, when I was looking at something that say that was red, the red value came up 12 to 16, whereas the blue and green were like in their 50s. When it was blue, the blue was between 14 and 19. And the red and green were in their 50s or 60s. So I knew as long as blue was between 14 and 19, I knew I had the color blue. And the same with green. Green tend to register right around 19 to 25 value. And the other 2 were 80 or 90, so they didn't, I just ignored them. So anytime either one of these 3 colors were within those ranges, I just assumed that was the color that was found. And that was the only calibration I did for this. The last portion here is the speech recognition module. I've done a lot with that. I just explained how to use the software. That was a matter of generating the code from this software using that button, and then taking the code that I had already for the color recognition module and just putting it in there like a case statement or an if statement. And actually, I think mine was just a simple if statement. Basically, if you find red, say the word red. Done. That was pretty easy. So all in all, the project was pretty straightforward. It probably could be tuned so that it's a little bit more precise, a little bit faster. I did strip out a lot of stuff because it does take a little while to process and for it to speak the word and then come back. So the fact that the car actually runs on its own is nice because that portion of the processing is not handled by the Arduino. And the Arduino can just focus on color recognition and the speech. The car kit that I ordered online for line tracing finally arrived. I chose to buy a pre-made car kit. It seemed an easier and quicker way to develop this project that I'm doing for line tracing and color detection. The kit is inexpensive and it's actually designed in a very creative way, so I wanted to kind of test it and see how it works. So let's see what comes in the kit. It comes shipped standard online shipping. It's wrapped up in foam, and this is what the kit looks like. It's got a bunch of components inside. These components you have to solder onto the PCB board, but it's pretty straightforward. You get a board with the components, you get a bag of parts, and I guess you get a little track that the car drives on. I'm going to make a bigger track and have it drive more, but the band has to be a certain width. I'm hoping to maybe minimize that a little bit more, but we'll see once I get it running. So that's good to have. Standard PCB board tells you where all the components go. The layout, that's nice to have. And then a bunch of parts. There's 2 motors, some wheels, a chip for driving it, and a battery holder, and some other little bits here and there. Of course, there's no instructions, so this will all have to be figured out and soldered on, but I think for the most part it's pretty straightforward. So that's the kit. Well, the car is now completed, and it's following the little track that comes with the kit, and it's a pretty tight little track. You want to make sure that it goes both directions. And here in this case it does. It's a pretty simple little kit. Works really well. Let me tell you about some of the issues with it. First of all, on the website they don't show you really the resistors, where they go, or any of the components or anything like that. And in fact, my kit is slightly different than the one that's listed or shown on the website now. But if you take your time and install each component one by one, eventually you can kind of deduce where things go. They don't show these here, these potentiometers, anywhere in the kit, and they also don't show the underside, which is something I definitely want to show so that you can see where the components on the bottom go, and that's these components over here, the LED and the photo LEDs, and where the wires for the motors connect and that sort of thing. In the instructions, they're a little bit unclear. They don't really tell you how deep to make or how far off these should stand off from the motherboard, the LED and the photoresistor. They say 5 millimeters, which is 1/5 of an inch. And how do you measure that? And then how do you solder it? It's kind of tricky. But what I did find out, and you can see that they're both the same way. Actually, this one probably should be move that out of the way so you can see it. They're about the same distance. I'm not sure that's quite right, but you have 3 adjustments to calibrate the wheels and that sort of thing. The first 2 are these potentiometers. You have to calibrate those so that the green lights flash accordingly and it steers back to the line. These potentiometers control, I guess, the sensitivity of the photoresistors, photo LEDs, and the other, I almost dropped it. The other option you have is to adjust the height of this leg here. I have it standing off. I had to add an extra nut. If you have it all the way up, the red light doesn't change the photoresistor LED, and it just goes off the track. So you have to lower this down until it just clears so that the light and the photo LED works. You also have to make sure that it clears the motor. Otherwise, the motor will drag on the ground too. So you don't want that either. I have it just barely clearing when you have the wheels and the motor. So that's another issue. The last thing is the wheels tend to fall off. So you need to find little screws. Let me get that in frame. Little screws to anchor the wheels to the motors, or else they keep popping off. So other than that, it's a great little little car. I'm going to change the track and make it larger and do more with it now. But overall, for $5 or $6, it works great. So this is the larger track, and you'll notice that the colors are on the same side, and they're out about ½ an inch because that's the location of where the sensor needs to be in order to read it. The colors are only 3 colors: red, blue, and green. There is a white and there is a black, obviously, on the track. And when you hear the car making a beeping sound, that means it's registering white or black. And when it finds a color, it recognizes the color and says that color. The track is about 15 millimeters wide, and it seems to be a good width and works fine. I could have made the track a lot more complex. You can't have the track cross itself because sometimes the car gets confused at the intersection. Also, the turning radius on the corners can't be too tight, otherwise it leaves the corner. And reading a color on the corner is very difficult. You have to have white in the periphery of the corner so that as it scans around, it doesn't read the flooring or something. So this is a slightly larger track. You can make it any size you want and have whatever colors you want, but as long as they're green, red, and blue, black and white. But other than that, you can configure it any way you want. This is the software that I use, the sketch that I use to control robot line following car and to speak out each of the colors. A lot of the code was generated by the speech recognition software, the Commander program, and some of it was the color recognition was designed by a sketch that I found online that was, I think, written at MIT. It's a small little sketch, very simple. So I just combined these two sketches, and this is what I came up with. So the top header here portion is for the EasyVR 3 module. I leave everything the way it is. I tried to remove some of this in the past, and it just caused problems, so I just leave it in. It doesn't take up very much space. Down to some initialization here. The S0 through S3 pins are set here. The output pin from the photodiode is here. Here we turn on and off, if you want, the LED pin. There's a minimum color range is 1,000. That's kind of a maximum threshold, and things are actually much smaller than that, so I just left it. Here we store the color name, whether it's red or blue or green, and then the color code, which is 0 through 3. 1 being red, for example, and then that's the number you use to print out, or not to print out, but to say the word red. So let's look at this S0 through S3. We've seen those before on the color sensitivity recognition module, and what are those for, and what are they used for? Here's a good chart. S0 and S1 actually are used to set the power to the scaling power to the actual diode. If you have both lines low, it's turned off, and if you have this combination, you can get between 2 and 20% power. And for me, that was not really, I guess, actually scaling. I say power, but it's actually scaling, not current. And I wanted full scaling. I wanted the whole thing. I wanted to recognize it as much as possible. So I have these. Actually, the MIT code has it set high, both of them to high, so it's at 100%, and it's always at 100%. Now let's look at the S2 and S3 pins. Depending on whether they're low or high, will detect certain colors, red, blue, and green. The clear, no filter, I don't know if it's clear or if that's actually white. I don't test for that color, so I didn't really use that. But that's what the S2 and S3 do. As you change these, it recognizes red or blue or green. So now that we know what these pins do, let's go back to the code and continue on. Here we have the void setup. We start right here. We do the PC serial begin 9600. Again, that's for the voice recognition. And then here's the TS3200 setup. It communicates at 115K rate, and this just prints out that it's ready. A little bit of a delay, so it powers up. And then there's more code here for connecting the voice recognition module. I leave that in. You probably could take some of that out and it would still work, but I just leave it in. It's not very much, and I wasn't really interested in dealing with that this time around. Here, this is important. Here, it has to detect the EasyVR module. Sometimes I get stuck in this loop and I know that it's not working, so you would definitely want to leave this in to make sure that it's detected. Once it's detected, it sets up some parameters. These are just set up by the code, a timeout factor, and then set the language to English. There's a group trigger, but I probably could take that out. I don't even have a group trigger here or used. And then you definitely have to leave this void action in. I tried removing it. It caused a problem. But in this case, I left it in. So now we're down into the loop. Here it starts to detect the color. It sets the minimum color to 1,000 as a default. And then here it detects the color and changes that minimum color levels. Here we read white, we read red, we read blue, and we read the green, and passes these variables to the color read function. We come back from that function, and depending on what the red, blue, and green values are, for instance, I did a little bit of a calibration and realized that when it detects a red, a blue, or a green color, each color is relatively low, like under 20 points or 30 points, or 30 comes back less than 30. Whereas the other, if it's red, it'll be less than 30, and the other two will be 80 or 90. So I just kind of trap for those unique colors. And then once I find an if statement that is met, I set the minimum color to red, the color name to red in case I want to print it out to the screen. The color code is 1, and then I play the sound using that color code. And that's at full volume. And I do that for the red, blue, and green. Now, if all of these colors are outside these ranges, meaning it's not one of these colors, then I check for white. And white will typically be under 5, a reading of 5. And then I set the minimum color to white and the color name to white, and I print it. I make a beep sound here. This 0 actually does a beep. I don't say the word white. Otherwise, if all of the values are greater than these values, at least on my test, then I set the minimum color back to 1000, the default, and I say, and then the name is black because it's found the black line, because it's going to be either black line or white color if it's not any of the other colors. And then I play the beep sound. So that's basically it. That's the whole program that detects the color and then says the color back. And this section here was part of the MIT code, and there's a float. You do a color read here using a float variable, and you pass these variables in, and you set this mode. This is the highest frequency setting. Remember, we were talking about those S3 and S2 pins, and it goes through here, and this is where it tests for white, it tests for red, tests for blue, tests for green. So these pins have to be set this color in order for it to test for green. So it doesn't read all the colors at once, it reads them one at a time, and this is how it does it. And that's why you need a color number so that you can trap for those. You probably could have used a case statement here too instead of the if. I just left it in. It was pretty clean and it worked. Here we do a read pulse. You got to read from the pin to see what colors you get back from this. And we set the LED off, but I don't ever turn it off. The LED state, I think, is always set to 1. I always leave the LEDs on because if you turn them off, there's a fraction of a second where these have to light back up, and I didn't have that time to do that, so I just left them on. They use a little bit more power, but I don't really care. So here you have to delay to actually turn them back on, so you actually could turn this off or delete this altogether because you're not turning it on and off. Now we go to read the pulse, and this is the actual value that we get back from the chip. We send these parameters, and if the pulse is less than 0.1, which basically is 0, which means it's off, we give it a default 80 hertz, and you can see that's what it says up here, 80K. You just cap it at 80K. It throws the numbers off, so they seem to figure that 80K is good, and it was good enough for what I needed. Here we return the value that we read of the pulse from the chip, and then here Taos Mode. Again, this is allows you to control the S0 and S1 pins. If you turn them off, the whole thing turns off. If you do the S1, S2, S0 high, this is the highest sensitivity. This is what I always used, and these are lesser sensitivities, and I didn't use those at all, but I left them in here in case maybe in the future I wanted to use them. Down here we have the last function. It's the setup, which just sets up the pins. The LED is an output, S2, S3, S0, S1 are all outputs, and then the only ones that input is what you read from the actual chip. And that is the code in totality. That's all of it. It isn't very much. So I hope that you use this code, and I hope that you enjoyed this video, and I hope you share it and subscribe to my channel. This is a simple project. There's two portions. There's one portion which is the hardware, which is building the car and actually soldering it, and then there's the second portion, which consists of two halves, the speech module and then the color detection. And those are all really software driven. So I hope that this program, the sketch works for you. Thanks for listening.